What is trigonometry? It is the study of triangles, and we focus on the measurement of angles in triangles. This refers to Chapter 5 of the prescribed textbook Pre-Calculus by Stewart and Redlin. And for today I will just be focusing on trig functions, special angles, and fundamental identities. As in my communication with you on my UNISA regarding your final examination, I have specified that there will be no information sheet in the final exam. This means that you will have to memorize all your trig formulae, your functions, your special angles, and your fundamental identities so that you can apply them in the final exam. Secondly, I've also reminded you that the calculator is not to be used in the exam. So today I'm focusing on examples which we can ask in trigonometry in which the calculator is not required. Alright, so let us start off by looking at what is meant by the four quadrants in which angles can lie. I have drawn a circle in the Cartesian plane with centre the origin, and this circle divides my Cartesian plane into four quadrants. So we have quadrant 1, which is specifically for angles between 0 and 90 degrees, or as we're working in radian measure, it's 0 to pi by 2 radians, remembering that pi is 180 degrees. Pi radians is 180 degrees. So that's quadrant 1. Those are our acute angles. If we move into quadrant 2, we are measuring angles between 90 degrees and 180 degrees, right? In other words, between pi by 2 radians and pi radians. So this is quadrant 2, and the angles which lie in quadrant 2, we refer to them as obtuse angles. The third quadrant is for angles which measure between pi radians and 3 pi by 2. So we have between 180 degrees and 270 degrees. So here we are going into angles which are bigger than 180 degrees, reflex angles. And then we have quadrant 4, which is between 270 degrees and 360. So 0 and 2 pi radians share the same terminal arm, and of course after 2 pi radians or 360 degrees we have completed a full revolution. So we speak about the terminal arm of an angle. So that will be the angle. I've chosen 5 pi by 6 to show you where does this angle lie, in which quadrant, and where is its terminal arm situated. Right, so the initial arm is always the arm 0x on the positive x-axis. 5 pi by 6, so we have to decide in which of these four quadrants does 5 pi by 6 lie. We don't need a calculator to do that for us, because we know that pi by 6, 180 divided by 6 is 30. So 30 times 5, 150 degrees. So clearly 5 pi by 6 is that angle which lies in the second quadrant, 150 degrees, because it's bigger than 90 and smaller than 180. So we're going to go into the second quadrant, and we have an angle here of 150 degrees. So this angle is 5 pi by 6. The angle is formed by the initial arm, OX, and then the terminal arm, which I'll call OP, because P is the point on the circumference that defines the angle 5 pi by 6. So when they speak about the terminal arm, it is this arm OP that they are referring to. Next, we look at how angles can be generated. Generally, it is positive negative. So if you look at positively generated angles, their initial arm has to be on the positive x-axis, right? And the rotation is always going to be anti-clockwise. So to get a positive angle, you need to rotate in an anti-clockwise direction, and the resulting angle will then be positive. For negative angles, as you may guess, the rotation is clockwise. So once again, from our positive x-axis, we rotate our angles, but this time we rotate in a clockwise direction. So that angle has been rotated in a clockwise direction, and it is now a negative angle. So for example, this would typically be at 45 degrees or pi by 4, and this would then be written as negative pi by 4. So the pi by 4 is in the first quadrant, and the negative pi by 4 or negative 45 degrees is in quadrant 4. But whether they are positive or negative depends on the direction of rotation. Trig ratios is the next topic. And first I want to define the three fundamental trig functions in terms of x, y, and r, and then we will look at their reciprocals. So again, we work in a circle of radius r unit. Remember, the radius is always positive, and it's always a constant measure for any point. Doesn't matter where the point lies on the circle, the radius is always that constant measure of the distance from the origin to the point. Just for this example, I've chosen my terminal arm, OP, to be in the first quadrant, and point P has coordinates x and y. So what I have here is a right angled triangle, and all the trig ratios are defined in a right angled triangle. So your textbook refers to right angled trigonometry. This is because in the next chapter we move away from right angles and we work in acute and obtuse angled triangles, and then we need to develop a different theory to solve these triangles. But for now, let us concentrate on right angled trigonometry. So our first trig ratio is called sine theta. Sine theta is defined to be, in terms of this triangle, the opposite side to theta, which is y, over the hypotenuse, which is r. Remember, the hypotenuse is in a right angled triangle is always that side opposite the right angle. Now, in relation to theta, x is the adjacent and y is the opposite. So that is what sine theta. Move on to cosine theta. And remember, what I write here are the abbreviations, which you will also see on your calculator. So cosine theta is defined to be the ratio of the adjacent side to the angle over the hypotenuse. So in terms of my right angled triangle, it is x over r. And then we have tangent, abbreviated to tan theta, which is defined to be opposite over adjacent. So it's y over x. Now, if you are defining your ratios in terms of opposite, adjacent, and hypotenuse, then it is easy to remember it by this little rhyme that we have sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent, SOHCAHTOA. Alright, now the reciprocals, if you remember, the word reciprocal means to reverse the position in a fraction of the numerator and the denominator. So the reciprocal of x, for example, is 1 over x. So the reciprocal of sine is cosec cosec theta is abbreviated by CSC. So, as I said, the reciprocal has to be the R over Y ratio. The reciprocal of cos is sec, and that will be the ratio R over X, and the reciprocal of tan is cot or cotangent, which is X over Y. So together here we have 6 trig ratios, and these are referred to as the fundamental trig ratios, which you work with in right-angled trigonometry. If you are not working in a circle sent to the origin of radius r unit, but if the question refers to the unit circle, as it did in some of your assignments, then we are dealing with a circle whose radius is exactly 1 unit. So these points will be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Alright, so if we go back to our trig ratios that we defined in the circle of radius r unit, then we have sine theta is y over r. Let's just, for example, look at that. So now in a unit circle, we said r is equal to 1 unit. So in a unit circle, you can replace all of the r's with 1, which means that in a unit circle, sine theta is just y. Okay, so if you wanted to label this point P with its coordinates x, y, then you will see that it will look like this, because now we have cos is x over r, which is x over 1, which means that cos theta is x. So now we know that the coordinates of the terminal point P will be x, which is cos theta, and y, which is sine theta. So that is, in terms of theta, the point P can be labeled as the point whose x coordinate is cos theta and whose y coordinate is sine theta. Alright, let us have a look at the signs of the trig functions, because we've now spoken about the 4 quadrants. So does the position of the angle in a quadrant affect its sign? Okay, so this can be referred to as the cast rule. Alright, so let's have a look what happens in the cast rule. So in the first quadrant, alright, in the first quadrant, quadrant 1, we have that all the trig functions are positive. So that would be the A in the cast rule. All the trig functions are positive. In the second quadrant, which is all angles between pi by 2 and pi, we have S. That means that sine and cosec, because if sine is positive, then its reciprocal must also be positive. So sine and cosec are positive. In the third quadrant, we will have T. T for tan and its reciprocal cot. And then in the fourth quadrant, between 3 pi by 2 and 2 pi radians, we have C for cos and its reciprocal sec. Okay, so that's why this is called the cast rule, if you read it from the fourth quadrant upwards. Or some people say it's all students take care, or all, in your case, all students take calculus. So that's how you can remember. So in the first quadrant, all the trig functions are positive. In the second quadrant, only sine and cosec are positive. In other words, the other 4 identities, the other 4 trig ratios are negative. In the third quadrant, tan and cot are positive. All the other trig ratios are negative, and in the fourth quadrant, cos and sec are positive, and the other ratios are negative. Alright, so let's have a look how we know whether it's going to be positive or negative. Let's just look at what are called reference numbers or reference angles. Reference numbers or reference angles are always those angles, those positive angles, which are acute and they are measured to the nearest x-axis. Okay, so when you quote a reference angle, it's not going to be an angle which is bigger than 90 degrees. It's going to be an acute angle. But of course, the examples that we are given are not going to be acute angles. So we have to use our reduction formulae in order to reduce obtuse and reflex angles to become acute angles. For example, let us have a look at t equals 5 pi by 3 radians. Okay, so clearly this is not an acute angle. Okay, pi by 3, 60 degrees, 60 times 5 is 300 degrees. So actually what we have here is an angle that is sitting, it's positive, so I have to generate anti-clockwise, and it is in the 4th quadrant, right? Because we are sitting at 300 degrees. So that is what 5 pi by 3 looks like. Now we have to reduce that angle and find the reference angle, which in your study guide we use the notation T bar. So the reference angle will be this angle here that I've marked with the dot, which is the angle to the nearest x-axis. And of course that is going to be acute, all right? So it's going to be 2 pi minus 5 pi by 3. You don't need a calculator to do that because you know that 2 pi is actually 6 pi over 3. So it's 6 pi minus 5 pi over 3. So that gives me pi over 3. So this angle here is what is referred to as the reference angle. Okay, it is pi by 3 and it satisfies everything that it's acute. You've reduced it, and that is your reference angle. So all angles can be reduced to reference angles. And because you're not allowed to use calculators in the exam, all your angles will be reduced to special angles. Right, so special angles are these angles. Well, we can talk about the angles 0, pi by 2, pi, 3 pi by 2. Okay, so those can also be regarded as special angles, and those we can read off because they're on the positive x-axis or on the positive y-axis or on the negative x-axis or on the negative y-axis. Okay, but I'm more referring to the other angles. So we can, in your textbook, they have given you the special angles. They've represented them in 3 different ways. So you can choose which representation you're going to memorize for your exam. They've given you it in a table form. They've given it to you in a circle form where the angles are shown on the circumference of a circle, or as triangles. Now for this particular lesson, I am just going to focus on the representation of the special angles in triangles. So it's pi by 3, pi by 6. Okay. So let us have a look at the pi by 3, pi by 6. Alright, so remember we are working in right angle triangles. One of these angles is going to be 60 degrees. Let's put it there. That's pi by 3, which means that as the sum of angles in a triangle is 180, the remaining angle has to be 30 degrees, pi by 6. Alright, so this is then, pi by 6 is your smallest angle, 30 degrees. Opposite the smallest angle comes the smallest side. The hypotenuse has to be the longest side, and by the theorem of Pythagoras, the remaining side has to be √3 units. So that is the special angle triangle. If you want to read off any trig ratio with a 60 degrees and with a 30 degrees. Alright, then we get the special angle triangle with pi by 4. So pi by 4 will generate an isosceles triangle because there's two equal angles and the angles opposite the equal sides have to be equal. That means that in this case I've got an isosceles triangle, and in this case I've got a scalene triangle because none of the sides are equal to each other. Alright, so in this example it's 1 unit. It has to be 1 unit, and by Pythagoras again that is root 2. Now using these two special angle triangles, you can read off any of those 6 ratios once you have reduced the angle to your reference angle. So for example, if I want to read off the tan of pi by 3, I know that tan is opposite over adjacent. So here's pi by 3, the opposite side is root 3 and the adjacent is 1. If I want to do the sine of pi by 6, I know that sine is opposite over hypotenuse. So now you look at pi by 6, which side is opposite to pi by 6? It's 1. And its hypotenuse is 2, and so on. So I don't need a calculator if I know my special angle triangles. If I want to do anything with 45 degrees or pi by 4, for example, tan is opposite over adjacent, 1 over 1 is 1. And that is why it's very important to reduce all your angles to these acute special angles so that you can just read off the ratios. Alright, so let us look at then how we're going to evaluate the trig functions. So there are 3 important steps in the recipe that I want to give to you today, because you cannot do it with a calculator. First of all, you've got to decide in which quadrant you're in, because you've got to decide whether your value is going to be positive or negative. Secondly, you need to work out the reference angle so that you can apply your special angle triangles. And thirdly, you need to write down the value without a calculator. So I have chosen 2 examples for you. Let us have a look at the first one. The cosine of 2 pi by 3. Okay, so 2 pi by 3. Let's do a quick little sketch. Oh, and I meant to say that you'll see that everything I do with you in your examples in trigonometry, I always do a rough sketch. Right? You cannot do trigonometry in a vacuum. The more sketches you make, the more triangles you draw, the better you will understand trigonometry. So 2 pi by 3. Okay, so pi by 3, 60 degrees, 60 times 2, so we're 120 degrees. That means that we're in quadrant 2. Okay, so we're in quadrant 2. We must establish the quadrant first, because we've got our all students take care rule. But now this is cosine, right? So I've established this is in quadrant 2, that's important. And now I know that in the second quadrant, S stands for sine and it's reciprocal. So that means that cos is negative, right? So that has established the sine. Right, the next thing we have to establish is the reference angle. Okay, so if we look at 2 pi by 3, okay, so it's 120 degrees, right? So the terminal arm takes me there. That is 2 pi by 3. Now in this diagram, in the second quadrant, this is going to be your nearest x-axis. So in other words, if you're working to the nearest x-axis, you're going to go pi minus 2 pi by 3. Alright? That is where you use your reduction formula to reduce it. The cos of pi minus 2 pi by 3. So in other words, the reference angle is pi by 3. To the nearest x-axis, what do I need? I need another pi by 3 to get to pi. So that's my reduction formula. Once I've done that, then I can refer to my special angle triangle. So I want the pi by 3 triangle, right? I do a little sketch here. There's my pi by 3. I know that Opposite the pi by 3 is root 3, and the hypotenuse is 2. So that's what I've got in front of me. So I want the cos of pi by 3. It's adjacent over hypotenuse. Answer, -1/2. No calculator required. Then, if you've got a negative angle, the procedure is exactly the same. You first put the quadrant. Okay, negative pi by 3. Right, in which quadrant is negative pi by 3? Remember we said that if it's negative, it's rotated clockwise, and so we're now in the 4th quadrant. In the 4th quadrant is negative pi by 3. There you are, it's generated clockwise. Okay, now that angle is in the 4th quadrant. All students take care. Okay, so tan is negative in the 4th quadrant. So I put a negative in front of tan. The reference angle here is the angle to the nearest x-axis. There it is with a dot. So it is pi by 3. Remember I said the reference angle is always positive and acute. Okay, so once I've done that, I can evaluate it. Here's my triangle. I've already drawn my triangle. The tan is opposite over adjacent, so it's negative root 3 over 1. Answer, negative root 3. All right, so that is how you evaluate trig functions without a calculator. Lastly, I just want to move on to the fundamental identities. As I said earlier, this is work that needs to be memorized. The reciprocal identities, cosec, remember cosec is the reciprocal of sine. So cosec is 1 over sine. Sec is the reciprocal of cos. So sec is 1 over cos. Cot is the reciprocal of tan. Please do not use the word inverse. Cot is not the inverse of tan. Reciprocals and inverses are two entirely fundamentally different concepts in mathematics. Tan is the ratio sine over cos, and it's very easy to prove these identities because you will use your ratios x, y, and r. And then cot, because cot is 1 over tan, remember you reciprocate, and so you get cos over sine. Okay, so those are referred to as the reciprocal identities. And then your Pythagorean identities, and again it's easy to prove these if you replace sine with y over r and cos with x over r. And remember, we're working in a right angle triangle, and in a right angle triangle we have the theorem of Pythagoras, which says that x squared plus y squared equals r squared. So using the theorem of Pythagoras, we're able to prove these three identities. Sine squared plus cos squared is always equal to 1. 1 plus tan squared is equal to sec squared, and 1 plus cot squared is equal to cosec squared. So to finish off, let us just do one example. Chose a particular example as has appeared in your assignments, and remember, any question that has been put into your assignments is examinable. Alright, so here's the example. If tan t is equal to -4 and cosec t is positive, determine cos t without a calculator, which is of course relevant to your module. Alright, so where do I start? Well, first of all, remember I said quadrants is very important. Okay, so what we notice is that tan is negative. Alright, so let's go back and look at my CAST diagram, and it said all students take care, and it was first quadrant, second quadrant, third quadrant, and fourth quadrant. Now tan is negative. Okay, so look over this and decide in which quadrants is tan negative. Well, first quadrant, it's positive. Second quadrant, yes, tan is negative. Third quadrant, tan is positive. Fourth quadrant, tan is negative. Right, so that information tells me that my answer can be in the second or the fourth quadrants. All right, so now the next bit of information will actually take your example down to working in one quadrant only. Where is cosec positive? Okay, cosec is clearly positive in the first quadrant where all 6 trig ratios are positive. Cosec, remember, is the reciprocal of sine. Okay, so cosec and sine are reciprocal. So you've got to look, where is sine positive? Sine is positive in the second quadrant. Cosec will be positive in the second quadrant. That means that cosec is positive in the first and second quadrants. Now remember, when I write these two, if this, comma this, it means if these two conditions are being satisfied simultaneously. Do you see where it is? In the second quadrant. So we are working in the second quadrant. We have established that we are working in the second quadrant. Okay, good. So now I can actually put my angle T in quadrant 2. There's its terminal arm. I now know that the angle T lies in the second quadrant. Okay, the next thing we have to see is how can we use the fact that tan T is -4. All right, we'll rewrite it. Any real number can be written as a ratio. Okay, so -4 can be written as -4/1. Now what was tan? It was opposite over adjacent. Okay, now you must be very careful when you construct this triangle, because we know that it's got to be in the second quadrant, but we have our angle T in the second quadrant. You see that the opposite to angle T cannot be negative because it's the positive y-axis, and the adjacent cannot be 1. So the negative that is there is actually 4 over -1. Okay, so remember that in mathematics, that a -4 could mean that the numerator is negative, or it could mean the denominator is negative. That is why I said earlier on that a diagram is essential. You have to know from your triangle now which is the side that is negative. And clearly in this diagram, the negative is the adjacent. So opposite to angle T is 4 units vertically, and adjacent to angle T is -1. We're on the negative x-axis. +4 for the positive y-axis, -1 because you're on the negative x-axis, and there are all the negatives, and those are positive y's. Okay, right, so if you want to work out any of the other trig ratios, it doesn't matter which one they ask you, you should work out the third side. So the third side is the hypotenuse. Okay, so it's r squared is x squared plus y squared. So x in this example is -1, y is 4, and so I get 17. The radius then is the root of 17. Okay, so the radius of this circle, or the hypotenuse of this right angle triangle, is root 17 units. Okay, so now I have a complete triangle. There is along the x-axis I have -1, along the y-axis I have 4 units, and the radius is root 17, and so now it is very easy to complete this. Therefore the cos of t, remember what cos is, it's adjacent over hypotenuse. Well, the adjacent is -1 and the hypotenuse is root 17, and so the answer is -1 over root 17, or if you want it in a rationalized form, it will be -root 17 over 17. So there are the 3 steps again: determining the quadrant to see what the corresponding to the sign, draw your triangle in the correct quadrant, get your 3 sides in your triangle, and then work with whichever ratio the question has asked. Thank you.